Hello. Right now, make sure that you have turned to page 7 in your note packet. So this is page 7 in your note packet. And also make sure to have out your Earth Science reference table. And you want to be on page 6 in your Earth Science reference table. So your ESERT. What we're going to do right now is do some notes on igneous rocks. And I'm going to give you kind of the brief version of this. So you're going to notice me skipping a few things to keep this simpler. Right now, go ahead and cross this off. We're not going to worry about it. So what is a rock? You're probably seen rocks before, so this should be pretty familiar to you. We've talked about minerals, and minerals are an important part of making up rocks. Rocks are a mixture of minerals. So I kind of like using the term mixture because when you think about mixture, it kind of indicates like there's some range and some flexibility into what you're going to be getting. If you think about the example of like chocolate chip cookies, um, not all chocolate chip cookies are the same. Maybe some cookies have more chocolate chips or less chocolate chips. Maybe they have more sugar or less sugar. Regardless of how much ingredients they have, we still consider them chocolate chip cookies. And rocks are very similar in that where they're going to have a range of different materials, like granite. Granite could have maybe some more quartz or less quartz, but could still be considered a granite. So you're going to see like a lot more um, ranges and things that aren't that's kind of more flexible in how we define things. So we're going to cross this off. An igneous rock, the first rock we're going to look at, is a rock formed by solidification of molten material. Molten material can be magma or lava. Molten just means melted. Okay, it sounds a lot like melted. So igneous rock is a rock that forms by solidification of molten material through lava or magma. Come on over here, we're going to draw a diagram of a volcano. Here's the ground. Here's the volcano. And we're going to label some stuff on here. First thing, go ahead and put some molten material deep inside the volcano. And then over here, put some molten material on the surface. So what we're going to do is label and diagram this figure a little bit. There's molten material on the outside. When it's molten material on the outside, it is called lava. And then this molten material that's deep underground is called magma. Because lava is outside, we say that the type of rocks that's going to form from this are called extrusive. While magma is intrusive. Now, if you think about this with lava, since it's extrusive, it's going to be outside, its cooling rate is going to be a lot faster. So it cools fast. And it cools fast because it's outside, it's exposed, it's not covered up like magma. Magma cools really slowly because it has a lot of rock and other stuff on top of it. That rock on the top of it keeps it nice and warm. The fact that these cool fast or slow is important because it's going to determine what the rock is going to end up looking like. So, for example, with lava, it's going to have much smaller crystals in the rock. The reason for that is because with fast cooling, the crystals don't have as much time to arrange themselves. They get cooled so fast and hardened that the materials aren't able to migrate and move around in a liquid material to form those crystals. With magma, because it cools so slowly, you're going to have big crystals. That really scared me. Big crystals. Another texture that's unique to lava is a texture called vesicular. Vesicular means it has gas pockets. As the lava comes out from the Earth's interior, there's a lot of gas inside, and as the pressure is taken off of that, the bubbles start to come out. It's a lot like soda. You might have experienced this where you take like a soda bottle and take off the cap. When you take off the cap, all the bubbles start to come out. Well, it's the same with lava. As the lava comes out of the ground, the gases start to come out. But those gases get stuck because the lava cools so fast, and you can see like little holes and gas pockets inside the rock. It's kind of cool, and you've probably seen that before, where like you're looking at a rock, you're like, hey, I think it's lava, or a lava rock, because it has like those little holes in it. What I'd like you to do right now is use those notes and fill in this chart below down here. So right now, please go ahead and pause the video and fill in the chart. Okay, welcome back. Let's go ahead and fill this in. I want to make sure you're okay with this. With an extrusive rock, it forms below ground. It comes from oh wait, sorry, did that wrong. So with extrusive, it is above ground. It forms from lava. It's going to cool fast and have small crystals. For intrusive, it's below, comes from magma, cools fast, slow, and you're going to have large crystals. And then for vesicular, remember we talked about that earlier. I know that wasn't originally in the chart, but let's go ahead and add that. Vesicular is going to go under extrusive or intrusive. That's right, extrusive. So go ahead and add vesicular. There you go. Right now, go ahead and turn to the next page. So page 8. And then we're going to go ahead and look in your eCert at some stuff. So this is what's called the Scheme for Igneous Rock Identification. This is how we classify and identify igneous rocks. It's different from minerals. Remember with minerals we use streak, luster, hardness to identify the different minerals. This time the two key things we're going to look at are composition and texture. Now composition, we're not actually going to like figure out specifically what minerals are in the different rocks. We're going to look at the color, and these are they're both closely related. Color gives us an indication of composition, and then for texture, texture is a result of crystal size. In other words, when I say a rock is coarse-grained, it has crystals that are 1 millimeter to 10 millimeters, or grains that are 1 millimeter to 10 millimeters. So the main ways that we classify or identify igneous rocks is based off of texture. And texture is really looking at the crystal size. And we also look at the composition. And we can figure out composition by looking at the color. And we're going to practice this a little bit. Before you do that, I'm going to kind of point out a few things. So what this chart is doing is it's showing you a lot of information. And I kind of want to just look over here first. So I'm just going to make a line going down like this so you can see this really clearly. And I want to look at granite right here. Okay, let's figure out what minerals are in granite. So for example, is potassium feldspar in granite? Yes, potassium feldspar is in granite, and you know that because it's in this column lining up with granite. How about quartz? Yes, quartz is also found in granite. What about plagioclase feldspar? Now the lettering over here is not quite in that column, but if you look, you can see the outline for plagioclase feldspar coming down here. This space right here indicates that plagioclase feldspar is also in granite. Let's look way over here, olivine. You'll notice olivine's not reaching into that column that matches up with granite. So olivine is not in granite, and so on. Like pyroxine's not in there. These other ones are. So biotite's in there, and amphibole is also in there. So what this chart's doing is it's trying to show you what minerals are in each type of rock. Now, like I was mentioning before, there's a range of minerals. It's not exact. Just kind of like the chocolate chip cookies. You're going to have different recipes, but still a chocolate chip cookie. And what I want to do is kind of to illustrate this to you. If you look at this spot right here, and I'm just kind of picking this randomly between here to there, you can see this is marking a certain percentage of minerals. To figure out what percentage that is, I'm going to take this down here, and you can see that it says like 20%. Okay, I'm going to bring this back now. So that's 20% there. If I move along here, you can see that the percentage of plagioclase feldspar is getting bigger and bigger. So if you look between here to there, you can see there's like a much larger amount of plagioclase feldspar. So as you move away from this first column here and go to this column, there's a lot more plagioclase feldspar. One thing that's a little bit tricky as far as figuring out the percentages is, like, say you had plagioclase feldspar and the percent was like 55%, or there's 55% plagioclase feldspar in the rock. Well, to figure out where that is, a common mistake, I'm going to show you the wrong way first. A common mistake is students will come over here and they're kind of like, well, here's 50, this is 55, and they come over and they're trying to find where it's like 55%. That doesn't work like that. Or this chart doesn't work like that. A better way of doing this is just kind of like making some kind of note of 55% like this, like on the side of a piece of paper. And you'll notice that, like, right here in this column, there's not 55%. So I have to kind of keep going over. And by the time you get here, you can see how, like, that line fits now for 55%. That's really how this chart works. I know it's a little bit confusing, but it is what it is. So with 55% plagioclase feldspar, I know now that I'm in this column. All right, let's try one together, and then you can try some on your own. So I'm going to come back to the questions here. This first rock is a rock that has quartz in it and has potassium feldspar. I also want to point out that it has a coarse texture. So I need all of that information to figure out what rock this is. So let's first start off with its ingredients, its composition. There's potassium feldspar. Here's quartz. Because it has both of those, then I know for sure that I'm in this column here. Now, that narrows things down, but you can see there's still a lot of rocks. There's obsidian, pumice, vesicular rhyolite, granite, and pegmatite. So think back, what's the other piece of information I need to figure this out? The other piece of information we need is its texture. So I come over here to texture. The texture is coarse, so I'm going to follow that across, and you can see that it narrows things down so that we end up with granite. So that first one on there is this granite. Write that on there. What I'd like you to do right now is please go ahead and find out the names of the rocks for these other different, so right now go ahead and finish this, like do the rest of these rocks, figure out what the names are. Please go ahead and click pause, and then you can check your answers. Okay, welcome back. Now, hopefully that went smoothly for you. It would be easier if I was there to kind of guide you through it and kind of answer questions, but here's what you should be ending up with. This one, you could get gabbro or peridotite. And I know that might be a little bit confusing that you can get like multiple answers, but that's just the way it works. If you ever have questions like these on a test, Usually it's multiple choice, and it will be really obvious which one you're supposed to go with because they'll give you specific choices. And it's not like they're going to give you two choices that are really close. They'll give you ones that are really far apart from one another. The next one should be vesicular andesite. The next one is scoria. And then lastly, obsidian. So that's how you use that chart, and that's a little bit of background on how you do igneous rocks. Again, we'll do a little bit more of this in class. You can ask me questions, and hopefully overall that you're getting a pretty good sense of this. Thank you, and talk to you soon.